Okay, so I'm Harper, and this is my research in anti-cancer projects. Although not the biggest killer annually, cancer can still be a very long and drawn-out disease. The current treatments for cancer involve surgery, radiotherapy, and chemotherapy. Cancer can affect anybody of any age, any health, and affect any part of the body. In 2011, around 435,000 people were diagnosed with cancer, and around 160,000 people died as a consequence of cancer in the UK alone, with lung cancer killing the most by far at around 22%. Now, the problem with current chemotherapy agents is that they are very toxic and non-selective drugs, which means that as well as killing the cancer cells, they also kill healthy cells, which is why we see the side effects commonly associated with cancer. One way to combat this is to use prodrug technology, where an inactive drug is able to enter all of the cells, but is only broken down in the cancer cells, which allows them to kill the cancer cells specifically and leave the healthy cells alive. In cancer cells, the concentration of some enzymes are elevated. So, our prodrug can enter these cells and then is broken down by these enzymes, releasing a non-toxic byproduct, which is excreted by the body, and an activated, highly toxic drug, which is responsible for killing the cells. Now, in some cancer types, such as lung cancer, you get hard tumours. Now, in these hard tumours, we experience a low level of oxygen, which is an effect known as hypoxia. Now, as we can clearly see on this slide, as the tumour grows, the concentration of oxygen is actually reduced. Now, due to the poor level of blood supply, these tumours are very hard to treat, as current chemotherapy agents cannot actually be transported to the tumour in order to act. However, we can use this to our advantage, because the levels of reductase enzymes are elevated in these tumours. We can actually direct our drug to act on these drugs specifically. So, to conclude the research, we have produced novel and new anti-cancer prodrugs, such as this one in the bottom here. We are currently modifying it so we can use it on other types of cancer, such as breast cancer, where there are soft tumours. Unfortunately, my partner company, Morbus, ceased to exist at the end of my first year of my PhD, so getting these compounds tested has been an issue. However, we hope to have them tested soon, as this will teach us a lot on how to proceed with the research. So I'd just like to finish by saying a few thank yous. I'd like to thank my supervisor, Dr. Murphy. I'd like to thank Morbus, my partner company, for their help and input that they gave me in the first year of my project. And of course, I'd like to thank Kes, because the research would not be possible without the money that was put forward. I'd like to thank you all for listening.